Hi all, welcome to the next topic of electrostatics. And last class we have learned about Coulomb's law and the three parts of Coulomb's law you have seen. So we are moving to the next topic, and that is called electric charges and electric field. The entire chapter will have like two subdivisions, right? Electric charges and electric field. So we are starting the core area of the chapter, that is called electric field. Okay, if you have not seen, or if you have any doubts, or if you are not clear with the previous sessions of video, first watch that and come to here, because if you are directly going and seeing all these videos from here onwards, you will never get any connections, because there are a lot of things which we have already learned it in Coulomb's law. We are going to apply will be here. So Coulomb's law part 1, part 2, part 3 videos are quite important. If you have not seen, or some unclarities will be there and there, please watch it and come back to this video. So without wasting the time, we'll move to the topic. So write on the heading electric field. Electric field. Okay, what is mean by electric field? What is actually mean by field? Field is nothing but an area. Normally we know in a cricket ground a field will be there, outside gallery. Similarly, in a football stadium also we have something called a field. So field is the area where certain rules and regulations are in place. If you are going out of the field, these rules and regulations are not available, which means it is a free area. Whatever I wish I can do that. But within the ground area or within the field area, there are certain restrictions are coming to picture. So the same meaning will be here. It's called field, and this is related with the electric. Electric means, electric field means charge field, charge area. Okay, what this exactly meant is that, we'll assume, suppose I have a charge plus Q. One charge will be here. I have another charge Q0. Okay, what this plus Q will do means, surrounding to this plus Q, one area, one boundary area will be created by the charge plus Q. So what this means is that the plus Q charge will have an area, and that is the boundary. This plus Q charge will have a boundary like this. So this means that the plus Q charge will influence on other charges. When any other charges which are coming to this area, this is its own area. So there are certain forces are available on this area, and this is called electric field area. Field means itself its area, so you don't want to mention this as area, electric area, or you can say electric field. So what will happen, this plus Q and Q0 is very far away from the boundary. This is a boundary. Now if I am taking this Q0 into this area, what will happen? Whenever it is coming to this border area, what will happen? This is a positive charge, this is a positive charge, so the plus Q will repel this one. Whenever it is comes to this boundary, whenever it is entering to the boundary, immediately this plus Q will repel this Q0 with a force called F. So field is an area where this charge, this is I am going to give a name called a source charge, and the source charge will experiences a force on another charge, and this charge I am naming to be as called test charge. So test charge is nothing but it's a charge which is used to test the source charge. So whenever the test charge coming inside the boundary area, the source charge will experiences a force on this one, and that is called a nothing but it's called an electrical force. So field is this area. Outside this area, no problem for the test charge. Whenever the test charge coming to this area, the problem will get starts. So what is the electric field definition is stated? Electric field E will be equal to the force experienced, the source charge on the test charge divided by test charge. Now we'll apply the equations. We know the equation for force. What is the equation for force? 1 by 4 pi epsilon 0 q into q0 divided by. I am assuming the boundary area is at a distance of r meter away. So it is called r square. This is what kind of force? Repulsive force, divided by q0 is the test charge. q0 and q0 get cancel each other, and we'll got 1 by 4 pi epsilon 0 q divided by r square. This is the equation of electric field. This is the electric field where? This is the electric field at a distance of r meter away. R meter away means the electric field available here. So the electric field at this position equal to 1 by 4 pi epsilon 0 q divided by r square. This is the definition of electric field. So field means it's nothing but area. So here electric field means the area created by the charge, and within the area certain rules are there. Certain rules means either it will attract or it will repel. Only that is possible when the test charge or any outside charge which is coming to this area. If it is not at all coming to this area and it is outside this area, then there is no problem. Whenever it is comes, the problem will start, either attractive force problem or it's a repulsive force problem, and that force divided by test charge is called electric field intensity. Okay, so hope you understood what is called electric field intensity. We'll move to the next part. So the right on the next heading, electric field in vector form. Electric field in vector form. We are going to see what is the vector form of electric field. We know electric field is a vector quantity because force is a vector quantity. So right side is a vector, so of course left side will also comes as a vector. Next, electric field is a vector quantity in the sense I am redrawing the diagram will be here. I have a source charge plus q, I have a test charge q0 will be here, and this plus q, the distance from plus q to q0, this is the boundary, is called r. So r is the vector which is directing from source charge towards the test charge. So I am writing the definition. E will be equal to 1 by 4 pi epsilon 0. Now we are in vector format, so we have to put an arrow mark, equal to q divided by r square. How we will represent a vector? Whenever I am writing a vector notations like this one, we have to multiply it with a unit cap, r cap vector. This already we have discussed in the Coulomb's law part 1 video, right? So vector E will be equal to r, because here there is only one vector. In Coulomb's law we have something like r12, r21 will be there. But here we don't have any such cases here, because at this point what is electric field? Electric fields are created by single point charges, but forces are created by a couple of charges will be there. One charge will attract or repel another charge. This charge will again attract or repel one the other charge. So there is a mutual forces are there. Here it is not like a kind of a mutual force, it is the field produced by one charge. That's what. There is no R12, R21 format, simply R format. What is the vector R, the unit vector R? We know the unit vector R equal to vector R divided by magnitude of vector R. If we are substituting this parameter will be here, denominator R square and this R will become R cube, and vector unit vector R cap will comes with the vector R divided by magnitude of R. So vector E will be equal to 1 by 4 pi epsilon 0 q divided by r cube into vector R. This is the vector form of electric field intensity. Okay, it is similar to the Coulomb's law. Here also we have a vector form for electric field. There we have the vector form of this Coulomb's law. That's what I told her. Definitely this is perfectly a continuation of your first few parts of your videos. I mean the first I mean to say like the previous session, the previous videos. So once you have clear with the previous videos only, you are able to understand what are all this concept. So this is electric field intensity magnitude format, electric field intensity in a vector format. Okay, So we'll move to the now two topics, electric field and electric field in vector form, and we are moving to the third topic. So write down the heading, superposition principle in electric field intensity. Superposition principles. You have to definitely have to maintain a note and you have to write the things, then only this will be there. Otherwise, if you simply hear it and leave it, you will never remember all these things, because electrostatic is it's a bigger chapter and many things will be there. So superposition principle in electric field intensity. I am putting as a in electric field intensity. So superposition principle in electric field intensity. What is a superposition principle? It states that, let's take an example. Superposition in Coulomb's law, we also have learned superposition. Superposition means it's a vector addition of all the forces in Coulomb's law. In electric field, it is a vector sum of all electrical forces. We'll take one example. Suppose if we have a charges, one plus q charge will be here, one minus q charge will be here, and I have a plus q charge will be here. Now I'm going to ask you what is the electrical force at certain point. For example, I'm considering this point. I'm asking what is the electric field at this point. Electric field at this point. So we have different charges will be there in different positions. Okay. So before we are going to find out the total electric field. Total electric field here means electric field due to minus q, electric field due to plus q, and electric field due to this plus q. So this electric field will have certain properties are there. The first property I'll tell you here, and later I will tell you the further properties. The first property is like the electric field lines or electric fields are always away from the positive charges. Let's take an example. Suppose I have a plus q charge. So the electric field lines are always outward. This is one property. This is the direction of electric field lines for a positive charges. If you are taking a negative charges instead of the positive charges, then the electric field lines are inward. It is into this one. This is electric field lines are into the charges if it is negative, and if it is positive it is outward. Remember, this property will have a set of properties will be coming in the subsequent sessions also. So now we'll find, because of plus q, the electric field will be here. I'm considering it is as E1. So electric field plus q means it is outward. So outward means this line will go like this. So distance from here to here I am taking as R1. Okay, so this electric field is called E1, and because of here it is minus q, I make it little clear. So it is minus q. So minus q will pull the electric lines of forces. So here there is one electrical force like this, and this is because of minus q. So I am keeping it as E2, and the distance from minus q to this distance is called R2. And I have another charge plus q. Plus q, the electric lines of force are away from plus q. Away from plus q means I have another force like this, and this is called E3, and this is at a distance of R3. Okay, now what I'm going to do means I'm going to take only this area. Now if you are looking, or if you concentrate only this area, you can see you have a force E1 like this. You have an not a force, electric field E1 like this one. You have another electric field E3 like this one, and you have another electric field and this is E2 left side, right? So left side it is E2. So you have E1 will be there, you have E2 will be there, now you have E3 will be there. Now you have to find out the total electric field will be equal to E1 plus E2 vector plus E3 vector E3. How you find out? E1 and E2 are in opposite direction. How you will find the resultant of these two vectors? These two vectors, the next step, these two vectors resultant is you will get one vector either towards right or towards left, depends upon the magnitude, but the total value is E1 minus E2. You will get a final vector. Then you have an E3 is like this. Okay, so E1 minus E2, E1 is right side, E2 is left side, so right minus left. So E1 minus E2, if you are getting this positive quantity, then it is in the E1 direction. If you are getting negative quantity, if you are getting E1 minus E2 as a negative quantity, then it is in opposite direction. So this is one chance, or you may get like this one, E1 minus E2. Depends upon if you calculated E1 minus E2. If you are getting positive, then right side. If you are getting negative, then left side. In addition, what is available will be here, E3 will be there. So either your final stage is like this, or your final stage will be like this one. Now you have a two vectors. I am assuming this angle is theta 1, for example, and I am assuming if you are getting this case, then your angle is theta 2. So in this case, we have to find the resultant of two vector. How we are finding the resultant of two vector? Resultant of two vector is equal to root of a square plus the general formula, a square plus b square plus 2ab cos theta. So if you are applying to this case, what is your a? A is your first vector. A means e1 minus e2 the whole square plus b means your second vector, e3. So e3 square plus 2 into e1 minus e2 into e3 into cos theta 1. This is one case. Cos theta 1 is your case. And if you are going with this things, then what will be the resultant will come in this case? Root of e1 minus e2 the whole square plus e3 square plus 2 into e1 minus e2 into e3 into cos of theta 2. That's all. So then we will find the final resultant. So resultant or the superposition of electric field intensity is a vector sum of all the electrical forces. So here the main concept you have to remember is like if you have a multiple forces will be there. Suppose you assume you don't have any E2 will be here. You have only E1 and E2, and if you know the angle between E1 and E2, you can find out the total resultant. How you will find out? Root of E1 square plus E3 square plus 2E1 E3 into angle between E1 and E3. Will apply to the same formula. But here you have three forces. It may be 3, it may be 4, it may be 5, any number. But irrespective of the number, we have to resolve the vector into a final form should be, it should contains two vectors. So all the other vectors you have to resolve it somehow. So here E1 and E2 in opposite. So you know E1 minus E2. We will subtract one vector with another vector. If E1 and E2 in the same direction, what you will do? You will add it, E1 plus E2, either towards left or towards right, left. Whatever, so you will add it, E1 plus E2. Here it is opposite, so E1 minus E2. That is will comes as one vector. Then the third vector E3 will be there. You will apply the resultant formula, and so that you will get the answer. This is what we are doing. This is actually not a part of this vector things, not a part of in the second year topic. In your first year two-dimensional motions, you have learned about this vector concept. Okay, so I just revised it here for your understandability. Hope you understood how we will find the resultant of two vectors. So we can always find the resultant of two vectors. In order to get to this miniature format from a bigger three vector format, somehow we have to resolve it and come to this shorter format. Then only you can apply this root of a square plus b square plus 2ab cos theta formula, and you can substitute and you can find out the values for this one. So this is a concept which is behind the principles, the superposition principle in electric field intensity. This is exactly same as the superposition principles in your Coulomb's law also. Okay, hope you understood this area. Next, we will see one example based on the concept of superposition principles. Okay, so let's take an example to understand the superposition principles in a very clear way. Suppose I have a charge plus q, minus q, and plus q like this. These are placed on a square of side A. Okay, so the question is asking what is the electric field at certain positions. Suppose I am taking at a positions will be here. At this point, what is the total electric field intensity? So here at this point, the total electric field intensity is taken as ET. Okay, so total electric field intensity at this point is how much? Okay, so electric field due to minus Q, electric field due to plus Q, electric field due to plus Q, electric field due to plus Q. This plus Q charge is at this point itself. So what is the equations of electric field? Now I'll say the total electric field intensity will be equal to, this I am given as 1, 2, and this is 3, and this is 4. Electric field due to one charge, electric field due to second charge, electric field due to third charge, electric field due to fourth charge. Electric field due to fourth charge is 0. Why? The charge, electric field at a certain point, the general equation is 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, Q by R square. Okay, R is the distance from that point. So what will be the electric field at that point itself? We cannot calculate the electric field at that point itself. It's in the middle of the charges. So whenever if it's going out with a certain distance only, the electric field can be calculated. So this part is not there. So only the electric field we are going to calculate because of the other third charges. So because of the first charges, the plus Q charges, this is a diagonal distance, right? So what is the electric field will be here because of plus Q? This is a square, this side length will be equal to a square plus a square. So we'll apply 1 by 4 pi epsilon 0 Q divided by a square plus a square, 2a square. So it is root 2a, and this is a vector format. And what is the direction of this electric field will be here because of this plus Q? The electric field is because of plus Q, it is away from the charges. Okay, so this E1 is away from the charges. So we'll keep it, this is nothing but E1, and I'm going to write E2. So E1 directions I know it is like this, and going to write E2 because of 2. So 2 is also away from this point. So the electric field is like this, and here electric field is like this. So E2 will be equal to 1 by 4 pi epsilon 0 Q divided by distance from here to here, it is A, and the direction is downward. Moving forward, what will be the electric field due to the third charge? This one, minus charge will attract like this. It is inward direction electric field. So the electric field is like this. So the electric field direction is 1 by 4 pi epsilon 0 Q divided by A. The direction is towards left. So this direction is like this. So now we will represent, we have a different vectors. One vector E1 is like this. Another vector E2 is like this. Another vector E3 is like this. Okay, now what you can do means you can find out the resultant of, if you are extending this one, this is like this. Okay, now what I will do means I am going to find out the resultant of E2 and E3, which is making 90 degree. So I can find a resultant will be here. Which formula again? A square plus B square plus 2AB cos theta. So A means E2 square plus E3 square plus 2 into E2 E3 into cos 90. This is the resultant formed by which one? Between E2 and E3. So E2 E3 resultant will come like this, and we have extended the E1 like this. Now we actually E1 will be there, E3 will be there, and E2 will be there. Now we have E3 and E2 together, we have resultant vector. So this diagram we can represent it as, we have a resultant vector like this. So we have a resultant vector like this, and we have an E1 vector like this. Now I am assuming this angle is theta. You can in the real questions cases you can derive this one if some parameters will be given, but for understanding this one. So the E total will be equal to, now again After from the 3 vector, now we come to the 2 vector cases. 2 vector cases resultant or the total is simple, r square plus e1 square plus 2r into e1 into cos of theta. If you apply this one, you will get the total electric field intensity at that point. Okay, so depends upon this cases, we have to apply and we have to find out this one. And the same model example, one example questions I am giving to you, you can try it out and then you see what answers you are getting to each other. Suppose here we have taking a square. Now I am going to take a equilateral triangle. Plus q will be here, plus q will be here, plus q will be here. Now I am asking what is the electric field intensity at the centroid point. At the centroid point. So how you want to find out for this case? I will give you a hint. You can try yourself for this question, sir. I'm giving just a hint to solve this one. You know, like electric field at this point, we have 3 equal charges will be there. So electric field due to one charge, electric field next charge, electric field next charge. So each and every charges we have to find the electric field. So electric field due to this plus q, it is away from the plus q, right? It is away from this plus q. So this is like this. This I am giving as e1. This is the one charge and this is second charge. This is a third charge I am assuming. So because of the second charge, electric field is also away from the charge. So the electric field is like this, and this is given as e2. And because of the third charges, this is a third charges, because of the third charges electric field is away like this. So you will get e3. Now you have a 3 vectors will be like this, right? Like this, e1 and e2 and e3. How you will find the resultant? You can find from the triangle concept. You have to find what is the angle between e1 and e2. There what you will do, you will find the resultant of 2 vector. How you will find the resultant? Root of e1 square plus e2 square plus 2 into e1 into e2 into cos of this angle. So this angle, if you find the resultant, then you will get the resultant vector will be like this. Now there is no e1 and e2. Now only you have a resultant vector like this, r vector, and you have another vector e3 in opposite direction, e3. Now from this one, now 3 vector is resolved into 2 vector. Now from this 2 vectors are in opposite direction. How you will find the total resultant? 2 vectors are in opposite means E total will be equal to the final. This E total will be equal to R and E3 will be there. So in this case E total will be equal to R minus E3. This will come for your answer. This is, I have written like this one, but you have to substitute really for E1, E2 and E3, then you have to solve it. This is a hint I have given. So it is not E1, it is not E2, it is not E3. This is just values I am taking as E1, E2, E3. You know what is the value of E1. E1 will be equal to 1 by 4 pi epsilon 0 Q divided by distance square. Distance from where? Distance from here to here. This point distance I have to calculate. This is an equilateral triangle. You can assume the side length equal to a meter. All sides are equal. So you can see one right angle triangles will be here. So you can apply the Pythagoras theorem and you can find out this hypotenuse, this distance, and that distance you can take it to calculate the value of E1. E1 value, E2 value, E3 value, magnitude wise all are same because all are equal charges and equal distance from the centroid pointers. So you know E1, E2, E3, and finally you will try to solve this vector and you will get the answer. Try to solve this one as an exercise and let me know what answers you are getting. You can comment it on to me. Okay, so ET will be equal to R minus E3 is the final conclusions out of this one. So this is just I have taken an example for you to understand about the superposition principles in a better way. Okay.